Welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. And we are back with unassemblize, building the GUI. And I think we should perhaps make one. What do we currently have? We have a bunch of pending changes, right? Right. Matched functions. Can we please? Right. So there is another consideration to have, and that is this here. Should there be a tree state? ASM matcher types. ASM matcher types. Where is it? Here. Is linked to source file. Can link to source file. Can be true or false. Can link to source file. Yeah. So currently, are we calling this guy? Let me see. Yes, we are. We are. Load source file for function assert is linked to source file. Yeah, okay. So I think this one should be a tree state, because effectively it can have three states, right? And then we say inside here, we say if so if not can link to source file, if not can link to source file, then we return tree state not applicable. Otherwise, we do if this is empty, then we return tree state false, else return tree state true. Yeah. Is linked to source file. Okay, so this makes it a little bit easier, I would say. Can link to, okay, and here has loaded source file. Has loaded source file. That is just a boolean. It's not just has loaded source file. Well, it can also be a tree state. Is set true if a source file load request has succeeded. Has loaded source file. Is linked to source file. Has loaded source file. So I think this would also be a tree state. And then we say if not can link to source file, then it's not applicable. Otherwise, if has loaded source file, then return true, else return false. Effect could become out of sync. Named function. Yeah, it's Can link to source file. Has loaded. I wonder if it really should have this flag here. Because as the comment says that source file is independent, so like this struct here, it doesn't own this thing. So it's questionable if this information should be here, right? Okay, so here we should say tree state true. Has no source file. Treat as success. Load source file. It's linked to source file. Can link to source file. Has no source file associated. Treat as success. Has no source file associated. Source file. Oof. Yeah. Can link to source file. I don't like this down here because it's disconnected. It depends on this. So maybe maybe we should have a separate a separate structure, a separate container that stores the state. Maybe. Okay, but how about we look at this in the follow-up change? Has no source file associated. Treat as success. Okay, how about we do tree state? Yeah. Const. Tree states. I can leave it. Okay, so it's true. Has loaded source file. It's not used. Is linked to source file. Build source lines for function. Can link to source file. Okay, so this thing will return not applicable. So I think what we do here is set it to tree state false, right? Yeah. Has loaded source file. Okay. Yeah, let's think about this as, think about this in another change. Okay, so that compiles. Good. So tree state. Now the question is, can we make this its own change or not? Why did we touch it in the first place? I don't know why. Probably used somewhere here. Maybe not. Okay, so that should do. Return tree state with named function, linked source file, and has loaded source file. Okay, and that is commit. Okay, then we stash this and see if it compiles on its own. Okay, then we stash pop, and now we also commit the other change. So matched functions disassembled. Matched functions disassembled. Is disassembled. Process matched functions async. Blah blah. Data commands. Here we just moved this thing. Maybe we should. Yeah, maybe we shouldn't move it in the same change. It makes it hard to look at. Let's search for this function. What's imgui app. Yeah, okay, and then we move it back to where it was, and that should give us a better diff, and it does. And then something else has started the processing of named function, but they are not yet finished. Add a schedule or a message or something. Yeah, so basically what we fixed here is fixes edge case, fixes edge case where matched functions could be processed on pending named function disassemble step on pending async named function disassemble fixes edge case where matched functions could be processed before async named functions disassemble has finished. Matched functions could be processed before async named function before named functions disassembling has finished. Fixes edge case where matched functions could be processed before named functions disassembling has finished. Yeah. Okay. Then we stash that. That compiles, okay. Then we do stash pop. Then we can move the function now. Move it up here to the other one. There we go. Okay. Move this. Move function. Move codes. Move function. Okay. So I'm not so happy with this thing here, because essentially the named function stores some information about the storage which it's not connected to. So this is not great. I think what we should do instead is have another file contents. What does this contain? Okay, so this is very general purpose. Maybe we should have like another container here where we like a bit mask, where we just say, which has the same indices as this, same length, and where we store bits in there, similar to how we did it in ImGUI app. We added this, where is it? Somewhere up here, far up here. Here in the process state, the processed item states. How about we create a new struct which gives us this functionality in an for isolated use cases? Which is not much code, right? Just a bunch of bit fiddling here. Yeah. Yeah. So let's see. Maybe we can create a new file here and call it, how do we call it? Bit container. Bit array dot h bit array. make a bit array dot cpp. Do we have a util folder? No, let's create one here. Util bit array, put it in there. Let's go to cmake lists, and we add a source util bit array dot h and cpp. Okay, then we compile. Okay, reload all. Okay, bit array, and then we create a we open the bit array here, and we put in this here bit array array with bits. Yeah, array with bits. Actually, hold on. Pragma ones we need here, and include bit array dot h, and so so we go to imgui app.h, and let's just create a copy of this guy, put it in here. Then we go to imgui app, and we create a copy of this guy just as a starting point, and we put it here, and then we do let's say bit array, and let's make it a class bit array, and we will have a constructor where we say item count, max item count, or just item count, counts size, and then we do con explicit. Oh, actually we don't need explicit, just bit array size. Okay, all right, and then here, then we have this, oops, that, all right, okay, and then we say bit size here, this thing, and fill. Let's create another here, default unt at default value, yeah, default value. Let's do default value default 0. Okay. We need to include memory and include int types types.h, I think maybe. Not sure. What header do we need for this? std int, maybe. Include std int cstd int. There we go. Okay, default value 0, blah 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 blah. Okay. So default, yeah. Then we need something like, what do we use it for? Set bit, get bit, right? Maybe we do, I mean, bits we expect just true or false. So let's do default value of false. Bit is just 0 or 1. So we can use a boolean to say this. Default value of false, bool. Okay. Bool. Okay, and then in here we say size divided by 8 plus 1. And we have this array here. Let's call this m bit array. Bit array. Yeah. And then we do this, make unique bit size, bit size, and then fill with default value. Yeah, fill. And then bits array get. There we go. Okay, so this is the constructor. Then next we put in it, we don't need. Then we will have a function set void set. We do size t index and value, bool value, and then get index bool get. Yeah, bit array bool, that makes sense. Well, does it make sense to return a bool? Yeah, because we only expect 2 states, so I think bool is fine. It's a 1-byte type still. Yeah, I think it's fine. But fill in, what is it? Const bool. Yeah. Get set get. Okay, simple enough. Okay, then let's remove all this. Then we add this bit array. Oh, Jesus. Okay, there we go. Okay, and set we do bit index is index divided by 8. Bit field is 1 shift index. Okay, bit field. Yeah, bit field. Okay, and then bit fields. Bit index. Right. I think. Hold on. Bit. I think if value, or let's say switch value, yeah. Case true, case false, yeah. Case true, we do this thing here. Bit array, and then break, and on case false we do bit fields. We do bit field equals invert, and then like that. Actually, we can just do bit fields. Then we can make it constant again. There we go. I think that is correct. Break. And then on get, we simply do get get is pretty much the same. This bit array gets index index return static cast. Static cast bool. static cast not 0. I think this is correct. Let's go through it. So we have just a constructor. We allocate the array and we fill it with the default value. Okay, fair enough. Then we set index value. Bit index is index divided by 8-bit field value bit array. Then we set this bit field, otherwise we remove it, this bit field. And if we get it, then we take the bit index bit field and we just check if it's set. Get index. Yeah, maybe it's correct. Maybe it's correct, yeah. Bit array. Array with bits. Yeah, the only disadvantage here is that like it's 2 steps here. Get. I would like a function that combines these into one step, because here in here we also have it in one step, right? We do this, then we check it, and if it's false, then we here return. So maybe what we can do is bit array get we can have a function that does both in one step. It gets and it sets. Yeah. How do we call it? Set and get? Get and set? Bool get and set. Get and set. And there we do bit array get and set. So we do bool results return results Results. Results equals this, and then we do this. Mm-hmm. Or we just don't care. And we just call get once and call this once, so it has to do this twice then essentially. Yeah. But I guess it's simple enough. There's a division. Here's another division. Yeah. Yeah, but it's probably so fast. Yeah. We could have another variant where we say yeah, let's remove this here and this. I think it's not worth it. Okay. So basically, the idea would be to replace now this guy here with our bit array. So we have here include util bit array, and we then put the bit array here. And we call this like so. Then we remove this guy. And then we remove, then we do here this guy dot no, bit array max item count default value formats. Inaccessible. What? Oh, right. So it should be public. Right. And we still need a default constructor though. Bit array Bit size, bit size, bit size. We should probably store also the size here. Size t, size. Zero. Then we have a size t, size, const. This also needs to be const. Size t. Then we do here const and return size okay, and then we can do here assert index smaller than m size. Let's do size assert. Same here. Include assert h, and yeah, just to have a little bit of safety here. M size, okay. Okay, and then we can remove this stuff here. Bit array, okay, and here we say index t. Index t. So we say capacity. So I think we can remove this assert because it will be implicit with the item states. So we remove this guy, and then we say here get index. So we say if get and index if, yeah, so if this is true, then return false. Otherwise, here this guy dot set index true, right? And then remove this, and there we go. Okay, and that's it. Yeah. So it's like a small simplification of the code we have in here. Now the only disadvantage is that computationally it's a bit more expensive on the first go because it needs to do the bit fiddling in here and then in here again. But yeah, I think it's so small, like we don't care. Yeah, it's immeasurable costs, I would say. Yeah, very likely immeasurable for our purposes, even on a billion of entries. Okay, yeah, so that basically we removed the logic from here, made this simpler. Okay, then yeah, let's see if this compiles, and then we also need to test if this works. Okay, it doesn't compile. Attempting to reference a deleted function. Ah, hold on. We didn't add the default thingy yet. I see. Unique pointer is default initialized to null. Yeah. Then here we can simply do default, if we can type correctly. Okay, and then maybe we should rename it to dynamic bit array. Nah, it's not necessary. Bit array is good. Okay, so let's go to MGUI app. Okay, so it did compile. We have put some breakpoints in here, so let's see if it runs as expected. Yeah. So let's make this large. So max item count 345. Let's step in here and that will set the size. Oh, hold on. Size is initialized here. Right. We need to set the size here. Size. There we go. Yeah, let's restart. Size. Okay, let's use M size here then as well. Okay, compare. All right, so bit array. Let's step in there. So M size, yep, is set. 44, that looks familiar. And now we have the array allocated and it fills it with zeros. I hope. Okay. Then, yeah, that should be done. M size 345, okay. And then get processed item count. Yeah, set item processed. Get items for processing. Again, set item. Okay. And now we need to select some function here. And that will go in here. So this should step over. We push. We set this index. Let's say 38, 128. Value, true, bit, break, done. Okay. And we got an assert. Okay. What is this? Oh. It's linked to source file. Oh, what happened here? Oof. Okay, we made some mistake here, apparently. Well, that's not good. Oof. Oh boy. Instructions 5. Name. source. Shit. What now? Oh boy. Oh man, why? I don't understand. It was the same before, no? What did we break here? If named is linked to source file or wait. Load source file for function. Load here, this one. Is linked to source file. Well, it's the same, isn't it? Can link, not can link to source file. Maybe there's an error in this function. Oh. No, huh? Source file name is empty. What was it before? Is linked to source file. Is linked, so return not empty is linked. It's the same as before. Why is it erroring now? I don't understand. Can link to source file is true. Did we... Can link to source. Can link to source. Did we maybe hear a mistake? Or not can link to source. We made a mistake somewhere. Right? Maybe here. Why am I not seeing it? Is linked to source file equals false. Oh, this is wrong, isn't it? Yeah. This should be not equal false here. If it's not false. Yeah. That's a little hoopla. Let's try this again. All right, compare. All right, let's click it again. All right, so get set item processed, pushback index set, da da da, okay, da da da, okay. Okay, no error. Now let's set the next one. And now if we go on here, it should now go in here, right? And it does. Okay, cool. All right, set item processed. Da, da. So the end is 2, begin is 2, get processed items, empty, done. Okay. And this is also false, yeah. Okay, I think this works now. So basically these are processed. Yeah, let's select all. Okay. Okay. Uh-huh. Mm-hmm. Mm-hmm. I still got the debug in, which is why it's so slow here. Okay. Mm-hmm. 15. Okay. Okay. Yeah, let's return tree state. Yeah, let's add a fix up commit for this one. For this, yeah. Commit. All right. Good. So the pending change, we essentially added now this bit array thingy. Okay, so this was step 1. The next step, we now want to use this bit array for the named function. So wait, to so essentially put a, where is it? So here we have name function and the file content storage, and then here we put a bit array m named functions. The question is, do we actually need this info? Sort of. Has linked source. Well, do we really need this info though? Realistically, because we can just look up in our file content storage with the let's see. Let's remove this for now. Let's go to ASM matcher types. Has loaded source file. Is this use? It's only set. Okay. Has loaded source file. So load content. It only loads if it's not already loaded, right? Yeah. So essentially, if we have a name function, then we can just check find content, and we just see. Yeah, maybe we don't need the bit array. Maybe we just test if it's in the file content storage, and that's it. Right? You pass the name here. It checks if it's in the container here. If it is, good. There is a penalty though, because there's no fast pass for failed lookups, right? Yeah, I'm not sure if it's worth it. I mean, there is a little bit of cost here. Like if we have if you pass a name here that is not in this content storage, then yeah, we pay the costs here for comparison, and here failed find. That's it. Some tests. So like there's some computational cost here, but it's probably what happened. But it's probably very small, so that it's probably Well, the most expensive part is probably like the data fetching of the map items. Yeah. Yeah. When there's cache invalidation. Oh, yeah. I mean, we could have bit array for this, but is it worth it? I don't know. Yeah. Yeah, I don't know. I think maybe it's not worth the complexity right now. So how about we just don't care. Yeah. Okay, so is let's remove this guy here. Yeah. And then here we return this guy, return, and remove this. And yeah, then essentially we can make this const, right? Const and name functions pair. Then we can also make this const. And then this const. And this. No. And some more here somewhere. Yeah. And yeah, name functions pair, disassemble, build source lines. Okay, so here put this and that. Make this const as well. Const. Why do we still have bundled thingy here? I don't know why. Okay, this also const. I don't know why we have this bundled function thingy here. Did we forgot to remove it? Yeah, we have multiple of these guys. I think they are not used anymore, aren't they? Yeah. Okay, well, let's remove that. Okay. And yeah. Do we have anything else? Oh, wow. Has loaded source file. Yeah, we remove that guy. And that's it. Yeah. So in our named function, we don't have now any information whether or not it's loaded, but it shouldn't, because named function does not own any file load state. Like, it's totally disconnected, so it shouldn't be in here conceptually. So I think this is fine, but it can link to source file because in our function we do store the source file name, right? Yeah, that is fine. Set source file. What does it do actually? It sets the line number in the instruction. I see. Good. Then technically we could remove this intermediate here from function. Maybe it's worth the effort to remove this guy. And we could also make these 4 bytes, and just like that would have saved 16 bytes already in here. This one in release is also smaller. This one as well, I think. So I think the struct can be shrunken quite a bit. Yeah. But okay, we can do optimization pass on data sizes another time. Okay, so yeah, we have now removed all traces of that thingy. Yeah. Okay, is that true if a source file load request has succeeded? The lifetime of the source file is independent, therefore could become out of sync, yeah. Okay, let's stage this, stage that, and And then we take this guy. Yeah. And this here. And this. Da-da, okay. And these guys. And this. I think we can make this just part of that as well. And go up. Yeah, okay, so this change simply, remove named function has loaded source file field, remove fields, that's remove, yeah. Okay, let's commit this. Yeah. Okay, let's stash the current changes, see if it compiles. Okay, then we do stash pop. And then we make a new change here for this bit array thingy. Index true, bit field. Bit fields. How about in our bit field, visits? Bit array. Set. Okay, so this one also here creates a jump table, which also has a tiny bit of overhead. So I wonder if we should have a set and the unset function. I mean, this implementation has a bit more overhead than we had it before originally. It was cheaper originally. Now with this abstraction, we added extra cost on top, which is really not much, but it is extra cost. It was faster before, factually faster before. We made it slower, marginally. Yeah. What we could do is we could maybe get rid of the switch by having a set and an unset function, but then set. what we can do is we create a template bool void set size t index. Put that here, and basically I will have the same implementation. If, well, we need bool value, if const expr value then we do this. Else okay, is that fair? So we would have a const expr version of this. So it's a little bit less work here. Can we get set and get? Can we merge this somehow? Like, can we return this before? Get value. Get. We should probably also make it inline, and we should probably remove this assert here. Yeah, how about we make it all inline? get size. Let's remove these guys. Bit array. Okay. So yeah, so it's all inline now, and yeah, set. I mean, actually, I think this is kind of stupid. We can just have a set and unset, right? And then we can just condition it outside, right? So just have a set here. Make a set and the unset. Remove this guy. So here, put this. Set. Put this. Like that. Set, unset, get. Size. Yeah. I think that is simple enough. And then we can remove all this. Actually, we can remove the whole file. Yeah. Okay, and then we simply do in GUI app here. We do set. There we go. Set index. Okay. Let's go to CMake. Oh, where's it? CMake. See here. Remove the bit array and remove this one here and done. Okay. There we go. Okay. Set, unset, get. Yeah. Okay, maybe we call this here not array because, well, it is array. Yeah, it's bit array. It's okay. Yeah. Okay, good. Then let's see once more if it works. Compare. Okay, blah blah. Okay, we click here. Good. Yeah. Okay, that works. Great. Then close it. Okay, then we take this guy. We take this guy. Tree and GUI app bit array. That's it. And this one. index. Okay, move move bit array construct move bit array from process state into separate bit array class. Okay, did we forget anything? Don't think so. Okay, commits. All right, good. Then let's stash this, and then we rebase, auto squash. I hope this will work. Rebase is always scary. Let's see. Okay, that has worked. So stash pop. Stash. Okay, let's check once more if it compiles. Default value. Now we don't have a default in here for this. I guess not a problem. Okay. False. Okay. Okay, let's push this current state. Next step, I would actually like to move out some of the stuff here from this class into new files. It's getting way too much in here. Like, for example, we can move this here away. We can move this away, and this one. Yeah. Okay, let's move some away here. ImGUI client. Let's put processed state .h .cpp and async work states .h async work states. Yeah. .cpp. All right. Good. Utility. So. CPP. Okay. Okay, once we got this done, I think we are done for today. Process state. So, processed state. Okay, and oh boy, process state. Async work states. Oh, I see. .cpp. Read cross. Why is it switching fire? No. Processed states. There we go. All right. So then we need this process state. Helper for imgui app. Helper for imgui app. Helper structs for imgui app. Okay, so includes process state.h. All right. Async work state. Oh, Jesus. Includes async work state.h. All right. Okay, and then here we put imgui app here and process state. And we put this guy here. And then we include comment types. Where's here? CSTD int. Span includes span. Includes common types. There we go. mgui app namespace GUI. Okay. Bit array include util bit array.h, and there we go. And now comment mgui app process state, and we take all this junk here and we put it processed state. Where's it? Pro here, put it in here. Then we do name, copy this here, put it there, and put it there, everywhere. Okay. Then we remove this and that and this, that, and there we go. Good. And then, okay, process state. So that is moved out of the way. And then we can go to mgui app, and here we do include processed state.h. There we go. Then we can also remove this guy. Don't need it anymore here. And there we go. Okay, so that is good. That should compile, I think. Yeah, it does. Good. Then we take process state. We make a copy of this guy and we put it in here. There we go. And then we take the same guy and put it in here as well. And then we take too many files. We take this guy. And here we make a copy of all this. We just take it, steal it, and we put it into async work state, put it in there, done. And then we go to mgui app and we take this guy and it's just a template function, isn't it? A template class work state. Yeah, all the functions are in here. Yeah. Okay. Yeah. Well, in that case, we simply include async workstate.h, and then we have a struct for mgui app. Did we have any? Did we have any hyperstruct to keep track of this kind of hyperstruct for app to keep track of items that are scheduled to be processed just once. Okay. Okay, then we can take this brief and we can put it in here. All right. And it looks like we don't need the CPP file. Yeah, let's see if it compiles. No, it does not. Okay, we are missing some stuff. Yeah. Okay, include cstd int and vector, include vector and anything else. There's an initializer list. Yeah. Maybe that's all we need. Let's see. Syntax error. Sized array. What does this take? Sized array. Oh, it's part of common types. Okay, well then we just include common types again. Include common types.h. All right. Then we remove this and we are done. And no, we are not done. Work queue command ID. Where is this being defined? In work queue.h. I see. Yeah, okay. Includes work queue.h. Okay, there we go. All right. Actually, work queue. It's probably also included. Yeah, it doesn't matter. Good. This looks good. And yeah. mgui app. Okay. Yeah, already looks a bit cleaner. We can probably move out some more stuff from here. But for this change, I think it's enough. Good, then let's remove the CPP file here, which pretty much contains nothing good. So we remove this guy, and then we compile again. All right. All right, great. Then we can take this stuff and submit it. So stage, data, async data, bit array.h. Yeah. Okay. And process state. Yeah. Okay, and then we say move I wonder if we should make this also classes instead of structs. I mean, it doesn't make a difference, but class, public. It's executable works. Class, public. All right. Okay. So move process state and async work state class move class process state async work state to separate files. Oh, what happened? To separate files. Move classes separate files. All right, I think that's good. Okay, maybe there's one more thing. This in the comment types, there's also the sized array thingy. It's really lightweight. Size array. Oh, I can leave it here. Guess. Good. Then let's push that as well. All right. Then I would say next session we move some more things out of this massive file. So we can move out the program file descriptor, the revision descriptor, and the comparison descriptor, because these are massive things, especially this guy here, because it has this struct in it as well, which is massive. Holy shit. Holy shit. Yeah, this stuff is getting out of hand. So I would say we try to move these out, and that should make this file much cleaner already. And then afterwards we can also maybe start cleaning up here currently the comparison manager body. It has all this junk inside. Maybe we can clean this up as well and put it into smaller functions. And then I think we have a cleaner state to continue with the next steps. Yeah. All right. Then, yeah, I will take a break here. I hope you enjoyed. I wish you a great day or night. Until next time. Goodbye.